In this video, we are going to talk about how to create an integral curve, right? So in the last video, we have seen that what are the isoclines and how to, draw the isoclines, right? But I didn't actually explain how you can trace the integral curve because there are other technical details which you need to follow, right? So let us draw, first of all, start with an ODE. Let's say this is the OD which you want to write. Let's start with a very easy problem, okay? But this actually gives you all the ideas which you need to do this. So essentially here we are not going to solve this problem. You see, this is a linear OD, right? It's very easy to solve this linear OD, but we are not going to solve it explicitly right now. What we are going to do is we are going to look at mm, try to get idea about how the solutions of this particular equation looks, okay, in the R2. So how does it behave just geometrically? Okay, so for that, what you need to do, first of all, we need to write down what are the isoclines. Okay, isoclines, as you remember, isoclines are lines where f of xy is equals to constant. So these are x minus y equals to constants. Okay, those are isoclines. So basically, these are you have straight lines. Huh? This is a family of straight lines. Family of straight lines. Okay, in R2. And of course, the null line is x equals to y. This is the that line. Null line is just for c equals to 0. Okay. So corresponding to c equals to 0. That's the null line. Now, so essentially what we are going to do is we are going to look at a curve such that at every point on the curve, y prime of x is given by x minus y of x, right? That's what we are trying to find out. So let us draw a curve and let's see what happens. Okay, maybe I can do it here. Okay, and where is it? Okay, let's draw this thing. Now you see, so let's say that's your y and this is your x. Okay, and the first line which we are looking at is a null line. Null line is x equal to y, right? So essentially, you have something like this, no? You have something like, sorry, I'm just, you understand, it's not very proper, but whatever. This is x equals to y line. Huh? It should be a little slanted. Slanted this side, but it's okay. X equals to y. Okay. So this is for c equals to 0. Now, how do you do these things? Yeah. Please understand this thing. How do you work out a problem? The way I did it, you don't do it like this. Okay. The first thing is this. Uh, don't write the lines, it will be more confusing. Write the slope. So c equals to 0. The first family is x equals to y line, the slope is c equals to 0. Okay, what you do is on this line, okay, on this line you have some slope. What is the slope of the, so basically whenever integral curve passes through this line, the slope of the integral curve should be c equals to 0. Okay, so we are going to draw some slopes on this integral curve. So what we are going to do is, first of all, we are not going to draw this line at all. Okay, we are going to draw the small elements of the line, which we will call the line element. Okay, and we'll draw it like this. Okay, these are small line elements. Okay, and now you draw the slope. Okay, once you draw the line element, you draw the slope, and for that I am using a different color. So let's say the color of the slope. So on this line element x equals to y, the integral curves, the slope of the integral curves must be 0. So 0 is basically 0, right? So the slope of the integral curves should be parallel to x equals to y, something like this. Yeah, that is the slope. Okay, right. Now let's draw, I don't know, maybe this is c equals to 0, right? Now let's look at c equals to 1. Okay, c equals to okay, so first of all, you have, for c equals to 0, it is x equals to y, C equals to, you do not need to draw everything, okay? Just draw 4, 5, and I think most of the times you will get an idea of how those things are behaving. So the second is x equals to y plus 1 for c equals to 1, okay? C equals to 2, it is x equals to y plus 2, okay? Now what you do is you have taken c equals to 1 and 2, now you take the opposite side. So c equals to minus 1, just look at it. So that will be x equals to y minus 1, and c equals to minus 2, that will give you x equals to y, I think I am correct, y minus 2. Okay, and you can go on doing this thing, but there is no need of this. Just take this part. Okay, so first of all, let's draw x equals to y plus 1. So x equals to y plus 1. It will look like this. Huh? It will. Okay, let me draw this thing. Huh? Okay, let me draw this. Okay, and another line like this. Okay, and of course here also we'll have some lines. Huh? So one second. It's very difficult to draw in this thing. Huh? So let's just one second. Okay. Let's just draw this line. I mean, the drawing is not very good, huh? But you understand. I mean, I'm drawing on this thing. It's not very easy to draw. Okay. So c equals to 1. So c equals to 1 is this line, right? C equals to 1. Okay. And I am drawing it like a straight line. Don't draw it like this. I mean, you just do it like a line element. Okay. It will be much easier to follow. So line element like this. Okay. Okay. And this is also line element. One second. So you draw the line elements and you draw the slopes on those line elements. Okay. So for now, let's just assume that okay, yeah. So let's just do this thing. So these are the line element. Now this is c equals to 1. C equals to 1 is x equals to y plus 1, and c equals to 2 is y equals to x equals to y plus 2. C equals to 2. This is c equals to 2. X equals to y plus 2. Okay, why I'm telling you not to write down the equation lines, but the slopes, because you will understand. See, c equals to 0, you just draw the slope. C equals to 1, you will draw the other slopes which is corresponding to c equals to 1. Okay, so now let's draw the slope. So now c equals to 1. Okay, let's draw this thing. So this is c equals to minus 1, c equals to minus 2, right? Okay, so let's just draw c equals to 1. See, if the slope here is c equals to 1, this is c equals to 0. Here it is c equals to 1. C equals to 1 is basically the slope is the same slope, no? The same slope. So it is something like this. Huh? Let's draw it like that. Okay. So what it means? It means that when the integral curve passes through this line, the slope is exactly, it will look like this, no? Okay. So this line is given by x equals to y plus 1. Okay. And similarly, if you draw this thing c equals to 2, so that will be a little more, so little more upwards. Okay. The slope is little upwards than x equals to 1. Okay, and it will go on, you understand. I mean, the more you go, c equals to 2, 3, 4, 5, it will go more up and up. Okay. So and similarly here what happens, c equals to minus 1. Okay, so the slope will look like this, no? This is c equals to 1, and c equals to minus 1 will look like this, huh? Slope will look like this, c equals to minus 1. Okay, I mean, this is just an approximating diagram. Huh? Don't worry about so much. Okay, and c equals to minus 2, it will look more, I mean, slanted down kind of thing. Huh? I don't know how to draw. I mean, this is very difficult. This is just an approximation. So c equals to minus 2. Okay. So now what is happening is this. See, I want to draw some lines. Okay. I want to draw an integral curve which when passes through this thing, okay, takes this sort of, um, I mean, it has to follow this direction field. Okay. See, you can understand. See, this is, I mean, the direction of this thing will be something like this, no? You see, it will go on doing this thing, no? So, mm, so let me draw the integral curve. So this is the thing. Now let me draw the integral curve. So integral curves is in green, blue, let's say. Okay. So see, it is coming like this. Okay. At a c equals to, this is the slope is c equals to minus 1. Here it is, and when it passes through this, it becomes c equals to 0, the slope. Okay. And similarly here also. So coming like this is here, it is c equals to minus 1, and when it reaches here it becomes 0, and it goes like this. Okay. And similarly here also. Okay. Here also. Okay. And here also you can see that the same kind of thing will happen. Okay. Same kind of thing will happen. Now the question is this: where does it go? I mean, does it cross this line or move it? Okay. So, there is another isocline. If you see integral curve, see this line. What is the line? This corresponding to c equals to 1. This, in this particular case, in this problem, c equals to 1. This is a very special case. That is why this is happening. It won't happen all the time. For c equals to 1, you can see that x equals to y plus 1 is a solution, right? Okay. So why? Because see, what I'm trying to say is, because this will satisfy y prime equals to 1, right? What am I saying? Yes, y prime equals to 1. Okay. And 1 is, you can see, this is x minus y. Okay. So you see, c equals to 1, this line, this integral curve, I mean this particular line, yeah, that is also an integral. So this is an isocline. Of course, this is an isocline because this is isocline corresponding to c equals to 1. Okay. And this is also an integral curve, right? This is also an integral curve. So basically this is a solution. Okay. So let's just see, this is an integral curve. I mean, you can just draw it like this. You can understand, right? Okay, it's an integral curve also. Okay, so you see, you can understand that as this app, I mean, though all of this somehow it looks like this approaches this line, right? This approaches this line. You see, all of this thing approaches this line. It looks like, okay, but the problem is this: what happens in this particular area? In this area, okay, what happens in this area? Okay, does it all merge together? Does it cross each other? So let's say after you go on like this, does it do these things? That's the question. You understand? After a long time, does it do these things, or does this thing happen? This is the question. Okay. Case 1, case 2. Okay. Here it is okay. At some point it is going towards this line. We can see. But what happens? In long term, does it cross it or does it touch it and become 1? Okay.